this is going to be a short introduction to computer science and how useful it is to help us in making decisions. So we're going to start with a why now. Then we will see some examples on how I use it to predict the future of healthcare and biotechnology. We're going to see how to gather intel and invest on NASDAQ biotech companies. At the end of the day, it is very important for a venture capital to understand public markets and listed companies, of course, because we invest today in companies that potentially could be sold one day or could become public. So keeping track of what is happening at the end of the road at our destination is very important, of course. And besides, seeing what's going on helps me in identifying the areas of maximum interest today and potentially anticipate how the market will evolve and how will the future of oncology look like, or the future of gene therapy, or the future of synthetic biology. You get it. I mean, that means in general the future of medicine. We'll see as well how to analyze any kind of data, COVID data, for example, or global data like databases. We'll see how to build even QUANT, an automatic program that invests in the stock market. We will understand a bit what is machine learning, and even we will cover as well artificial intelligence. So we're going to go from simple to complex, covering all the things that I've mentioned. But let me tell you a disclaimer first. This is not meant to teach computer science, or more specifically Python. This is meant just to open eyes. I mean, it is not about how to write code, but about its possibilities. So sometimes you're going to see me fast forwarding the video when I'm writing code, just to spare you the waiting time. Without further ado, let the video begin. So let me first explain what is this. This is a Jupyter notebook, and we're going to use these cells to code in Python. So for example, I could instruct the computer to print the word hello in the screen, and as you can see, it has printed hello here. Or I could instruct the computer to print the first 10 numbers. So this allows us to go cell by cell, coding, and in a very straightforward way. So I'm gonna code a very simple function that is gonna tell me if a number is a prime number. And bear with me, because even this is not life sciences, this is gonna become very important to understand why now. So this function is defined already. Let's check it and ask if 7 is a prime number, and it says it is. Or let's check it again and ask if 12 is a prime number, and it tells me it isn't. Okay, if I check, for example, a very large number, say, I don't know, this number, it is not a prime. But to know if this is not a prime, it needs to divide itself by 2, 3, 4 until n. So all the numbers until the end. So it's a very computational intensive process. So now comes the important part, because I've been coding since I was a kid this loop to find the first prime numbers between 1 and 10,000. Let me write it really quick. Okay, so now it's coded, and let's see what happens if I execute this. I mean, it was so fast. Well, in fact, yeah, I need to add a 0 here, but it was so fast that literally, I mean, I can't even see what the computer is doing. So just for the sake of clarity, let me just add a couple of instructions here. We're gonna time the process, and I'm gonna add as well the dictionary here. Is going to be more clear, and I'm going to append here And finally, I'm gonna write over the same line. That's it. So let's do it again. And now, as you can see, it took just close to 500 milliseconds to find out the first 10,000 primes. Let me just print them all, just for you to see what it did. And here is the list. So the thing here is, when I was a kid, this took like hours. 5 years ago, it took seconds, but today it is taking 500 milliseconds. So here you have the reason why now this technology is going to become very, very important, because simply we already have the speed to perform very complex instructions, such as, for example, machine learning or artificial intelligence, as you will see at the end of this video. And let's start by gathering some intel on NASDAQ biotech companies. One of the most interesting things about Python is that we can import libraries that have already been coded by someone else. For example, I imported now Pandas, Y Finance, and Tally because I'm going to use those libraries. And if you're curious on what Y Finance is, for example, you can always write this and read here exactly what it does. This is a module that allows me to import directly from Yahoo Finance financial data about listed companies. Okay, so let's start, for example, by defining here a stock, and you will understand why I'm defining it now as a variable, and this is Moderna. And let's use the Y Finance library to import some data. Okay, so now I have in this variable sec the data about Moderna, and I can see it. For example, we could just do this, and here we have lots of data about this company. If I want to access a specific part of this data, for example, let me find here market cap. Yes, it is here. Let me copy that, and I could always return here and say, and now I'm getting just the market cap of this security. But let me just proceed as well and grab the history of this security. And I'm going to grab the history for a period of 1 year. Now I have this, and I can print, for example, the first 20 rows of this database. And as you can see here, I have the open, the high, the low, the close, and the volume for the last 365 days. Okay, and now here I'm just seeing the first rows of this security. I could even plot this, for example, plot the close, and yeah, like this. Sorry, I misspelled one word. This is one thing about Python. It's very precise, and you need exactly to tell the right name of the variable. You can see here how Moderna has performed in the last year, and I could even do this in a more fancy way. Just give me a second. As you can see, we just printed here the, excuse me for that, we just printed here the curve of Moderna stock for the last year, plus this orange line, which is the simple moving average. I coded it here just using the Talib library that we imported before as well. So it's a very fancy way of seeing how a company is performing. But
bear with me because this is important. If I change, for example, here the Moderna stock, as I coded it in the form of a variable, and I introduce, for example, the NASDAQ Biotechnology Index, I just could repeat exactly all the steps and I would get the NASDAQ Biotech Index. By the way, not a very good performance in the last year. And for example, just 10 years instead of 1 year, and I repeat everything. And then here you can see the performance of the NASDAQ Biotech Index for the last 10 years. Let me move forward and let me show you that I can use as well my own coded libraries. And now what I did, I just imported one library that I wrote myself, and of course a library that I wrote modified from someone else's library that at the same time was modified from someone else's library. And now I coded here some plots that I usually want when gathering intel from NASDAQ biotech companies, and let me show you how it works. So now I'm using my own code to show, for example, the cumulative return here, the drawdowns, the daily returns of, in this case, remember we were seeing the NASDAQ Biotech Index, so we're performing this analysis on the NASDAQ Biotech Index. And I can, for example, as well, the underwater plot, or I could show you the periods where there was a drawdown here, or even more interesting, the monthly heat map of this NASDAQ Biotech Index. Let's remember once again, just to show you the potency of all this, that I can change this, for example, and use the security fate, and use Fate Therapeutics. I can repeat everything very quickly until I have exactly the performance of this security, and the system recalculates all the things that I need to know about this security. So as you can see, extremely powerful. A couple more examples. Here we have, for example, the rolling volatility for the last months, or even one specific thing that I coded, which is simply all the graphs that I have in full, just to get a glimpse very quickly on the overall security. So here, for example, we have performance metrics, we have 5 worst drawdowns, everything that you can imagine, all the info, distribution of monthly returns, rolling Sharpe, rolling Sortino, etc., etc.
So we are going from simple to complex, and the rest of the video we will be increasing the complexity. And this means, of course, that we will be able to do more interesting things. So, because once you learn the language, Python, you can speak it and instruct the computer to do whatever you want it to do. So let's try now with more than one listed company at the same time to, for example, try to find correlations between them, correlations that we may be able to exploit. So what I just did was to define this list of symbols, and this is going to be treated like an object on itself, and treated as just like one symbol. So it's very simple to move from one symbol to a list of symbols. And then I made the computer read from the web, from Yahoo again, the information, and now we do have like a database that I'm showing here. But in fact, what we want is not this database, but a pivot table, exactly in the same way as we were using Excel. And now we do have here this pivot table where, as you can see, I have the date. Of course, I instructed the computer to retrieve information from 2017 until now. And I have here at the beginning of 2017 the close of all these companies. Of course, BTX wasn't there yet, and Pali wasn't there yet, but of all the rest of the companies, CRISPR, Editas, Ionis, etc., Regulus, we have the close here. But now we can precisely correlate the performance of those companies to try and find a relationship between them. And now we do have here then the correlations between all these companies, but of course it is much more easier to see those. These are the actual correlations, but it is much easier to see the correlations in a graphical form. Let's write it down here. And we do have here already the correlation. Still, I'm thinking an extra steps here just to see it even better. Wait a minute. And now we're done, and we see here exactly how all these securities correlate with each other. But I'm thinking, final step, let me just add here, because what we are really interested in probably is not the correlation between them, but as well at least the correlation with the NASDAQ Biotechnology Index. So I'm just adding one security here, which is the NASDAQ Biotech Index, and I'm repeating exactly all the steps, and then the computer is building, and here we have the correlation with the NASDAQ Biotech Index. And here in this column, or in this row, you can find exactly how the correlated were those securities with the NASDAQ Biotech Index. We could do many more interesting things here, but this is, I mean, the purpose of this video is just to show you how it works and the possibilities of this tool. And let me show you now how I find information about new IPOs or the performance of new listed companies, because we're gonna tie it all together and you're gonna see how useful it is. So just to get warmed up, I just imported here some other libraries to get more information about companies, and I chose this company precisely to Medeo Biopharma Group to see a little bit what they're doing. But now, I mean, let me just code it very quickly. What I just did is to print all the insider trading that this company had in the recent days. This is December the 8th, the 7th, etc. And these are insiders that did transactions. This may be very important to see where the company is going. And I even coded a very quick way of retrieving all the information. I'm sorry because you won't be able to see this because of the computer resolution here of the screen. But this is a list of all the last year's IPOs happening in biotech. So we have here all the IPOs. I'm gonna just for a second gonna move this even if you won't be able to see it correctly, but at least you get the feeling on how the list is. Not sure if you're seeing this correctly, but never mind. So let me just exactly. So here we have all the companies, and as we did before, I can grab this data frame and use it, find things that I want to know about these companies. We have here these columns, the beta, the average true range, the simple moving average, the highs and lows of these 52 weeks, and therefore we can see the performance of all the IPOs. Let me tell you, the performance of the IPOs this year has been very poor so far, but that's how it goes, yes. So let's move on to another topic. But of course, as you can all imagine, the real power of these tools comes when you import your own databases. And I'm going to show you, just as a disclaimer, I'm going to be using an old, and I insist old, this is March 2021 file, just to show you that, because I can show you my real database today. This is, of course, confidential information, but as well, I don't want anyone to draw any conclusion from the data that you're about to see. But this is just, I'm going to show you my Excel file with all the companies at the NASDAQ space. You can see here the list of the tickers. This is, again, it's just an Excel file. I have here close to 1,000 companies analyzed, and I just look into every company and think about the future of the company, think about the things that are coming on, the pipeline that they have, if they had the IPO, how it was. I'm ranking just the wow slide and how powerful is the indication to invest, and how easy it is to prove, whether if it's leading edge or not, the biology dark it uses, and a bunch of, I mean, a lot of indicators. And here I have as well the performance, the monthly performance, quarterly performance, etc. And well, as you can see here, it's quite a complex database. Let me minimize that. But because now what I'm gonna be doing is importing that database into Python, and you're gonna see what you can do with that. So now I have exactly the same database that you were looking a few seconds ago, but now I have it in this format. Now I can perform correlations in my own database compared to all the Python data that I've been able to import in the previous minutes. So let me just and here we have, of course, it's a very long list. You've noticed how fast it was. It was milliseconds to correlate everything. But again, I'm going to use a more graphical interface to understand the relationship between the data. And as you can see, it took just a couple of seconds, and here I have the map of all the columns that I had in my database. We can find here in the middle the actual performance every week, every month, every quarter, every year, etc. And I can see all the variables that I'm using, exactly how do they correlate with the final performance of the company. I can tell you how valuable this has been for me, and just to trying to predict in the future what new areas will come to venture capital in biotech, etc. So of course, I cannot go through the data because, again, this is confidential. But I'm sure you are starting to feel how important this can be, just to know about the future of biotech. The important thing to understand is that the database that you just saw, it's fully automatized. I've been able to code ways to extract that information, so it's very simple to maintain. And now this next part is going to be a bit more technical, because I'm going to show you very, very quickly, and only for those of you interested, how to build up on all the resources that you just saw to code a quant. A quant, it's a special program that is able to invest on itself, in my case, at the NASDAQ biotech. So let me just show you for a second what I built over the years. This is, of course, something that is long, and it's been many years doing that, of course, but this is just my structure for my own quant. For those interested, I'm happy to share it. And but I'm not going to go through all that structure. What I'm going to do instead is show you very quickly how a program to invest automatically and do back trades to test it before at the NASDAQ looks like. And this is just, I mean, I gather the data, I build the data frame, and then this is the logic that I use. Of course, again, I cannot disclose the logic that I use, and in any case, all the alpha scores that I have are run in a separate notebook. So because of course this is highly confidential, and but in any case, you can see here how I can run back trades, and I have here the performance that I achieve at every back trade with outliers now and then. So this is not perfect, of course, and it gives you not perfect data, but I'm able to optimize my own scores, and I'm able to perform live trading using those systems. So even without looking at the computer still is trading. Let me show you another one, maybe one that it's live at this moment. These are just plain just to see how the different variables that I use correlate with each other to try and find the best optimal scenario. More correlations, more regressions here. And then here's the part where I do live trading. And this is actually, as we speak, trading live. But again, I can't go very deeply into that, but just to let you know that it is possible to use all this to program the computer to invest on my behalf. And so far, I'm very happy with the results that I achieved. Well, but some of you may think that this is very interesting, but it is very limited only to NASDAQ biotech companies, for example. But I'm going to show you now that actually a lot of information is already available. And I'm going to show you how to grab any database that you want to from the internet just to feed your own data. So, for example, I'm going to find one database that I like, that it's here. Yeah, I have it here precisely. So it's worldometers, and then it was COVID, that here, and here I think I have, yeah, that's the web. And you can find here several databases or data frames with information about the COVID. For example, this one. There's one specific trick of every web page. You can always right click here and say inspect element, and then here you may grab exactly the name of the data frame that you are seeing here. So I just need to copy and paste this, and then let me go back here and let me code very quickly a way of downloading all this data automatically to my computer. As you can see here, I just imported exactly the same data frame that we had here at this page. Let me close that. And now I got it on my own computer just to do whatever I want with it. And let me show you things that we could do. I just rearranged the data frame and I sorted by cumulative cases. And now finally, I just removed all the continents and see the actual data per country. Okay, so here you have all the countries, and here you have in the columns then the population, the weekly count, rate for 14 days, etc. And finally, I might be able to print the curve of new cases per country. Let's do that. And look how quickly I was able to code the computer just to let me know exactly how the different countries are doing. So of course it looks like very complex because you're not used to this kind of code, but this is just like speaking a language. It's like speaking French or English, or and then being able to tell the computer what to do exactly. And if you are precise enough, you can do extraordinary things. So now I'm just looking at the Spain data. We can see here all the waves and everything, and we can see how this is getting a bit more complex now. Let me change very quickly Spain for Germany. Now we can see Germany is really doing bad, you see. And very quickly as well, you can see I can draw the chart with many indicators. I mean, this would be the deaths and the cases and everything. So I can have my own opinion, not on what the media says, but the real data that I can extract from the internet, from real databases with everything that's going on. So it's a very useful tool to extract information out of databases on the internet. And just for fun, I just coded very quickly the correlation between several variables, the population and what happened last week, just to have a glimpse on how the number of citizens correlates with the incidence of COVID. But I'm just showing you a little bit how it works.
So bear with me because it's very important to understand the math behind the artificial intelligence systems. Because once we understand the math, we understand as well why they are so incredibly powerful and why they are so effective. So let's suppose for a second we have a study in patients and we measured some variables, X1 and X2 here. And for example, X1 it's a surrogate biomarker, and X2 is a clinical score for a patient with glioblastoma. And we know in every patient, this is patient number 1, patient number 2, patient number 3, patient number N, and we know that this combination of this biomarker and this clinical score correlates, or in fact, in reality, the patient did have a glioblastoma. The second patient didn't have a glioblastoma, etc. Okay, so it is very important to understand the difference between coding an algorithm, the traditional way of doing things, and training a machine learning system to understand the relationship of these variables. Okay, so the traditional way of doing things would be, we do have the data because we conducted this experiment, and we try to imagine some rules. This is set by us. We imagine the rules, and then we write a code, and that would be the traditional way, an algorithm, and then we find the answers. In this case, a prediction, whether the patient has or doesn't have a glioblastoma. Okay? So, bear with me. Now we're going to change to the machine learning setting. We do have the data because we conducted these experiments, and we do have the answers. and we want the artificial intelligence to find out the rules. Okay, so it is a very different approach. This would be machine learning, and we could set that in a way that we do have a hypothesis here, and for that hypothesis we're going to introduce variable number one, x1 and x2, and if some calculation that we do here is above zero, for example, we could conclude there's a glioblastoma. Okay, and this calculation is like variable 1 multiplied by a weight and variable 2 multiplied by a weight as well. And we could add here like another weight. It could work like the intercept in traditional regression techniques for those who know about math. And this function would provide us the answer whether the patient has a glioblastoma or not. So let's change this way of seeing this hypothesis into a neural network. Okay, so and neural networks, as its name implies, are programmed exactly in the way neurons work in our brain. So now we do have a neuron here with the variable 1, and we do have a second neuron here with the variable 2, and then this symbolizes like the weight, and then all we're going to do is to sum, this result or this outcome is going to be x1 multiplied by the weight 1 plus x2 multiplied by the weight 2. So this sum is going to be the outcome. Okay, so this function, we could write this function like the sum of all the weights per all the variables plus this intercept that we were mentioning here. Okay, but I forgot to tell you about this parameter here, which is very important. This is called the activation function, and is what makes the system resemble a neuron, right? Because this activation function says that this result is not just the sum, but this result is converted in a way. For example, we could convert it to a function that activates. This would be a 1, this would be a 0. Once you exceed a threshold here, or we could do like a sigmoid function like this between 1 and 0, or we could do, for example, I don't know, there are many systems, what is called a ReLU, that goes like this, and negative weights doesn't matter, but positive weights, they increase. And this already transformed this function into, from a linear function into a non-linear function. And this is going to be extremely important. The real network is something like you see here. It's the inputs x1 and x2 or variables, and then we introduce here some layers. We call them hidden layers. Here we have a hidden layer number 1, and then here we have a hidden layer number 2, and the system works like this. And this is the most important part. Of course, the variables here, x1 and x2, go through this system of layers of neurons, and then it provides an outcome, a result, a prediction that this patient has glioblastoma or this patient has not a glioblastoma. So we start at first with random weights. This weight 1 and weight 2, this is weight 3, weight 4, etc. It's full of weights. We start with random weights, and then we do what is called the forward propagation. It means that the signal goes through every layer until it reaches the end and comes to a conclusion. And now, this conclusion, remember, we know here what was the outcome. We are training the system. This conclusion gets compared with reality, okay, and it checks the result and with what is called a loss function here, okay. And this loss function tells us how different is the result from reality. And based on this difference, we do the next step is what is called the backwards propagation. And now the signal travels again backwards, adjusting all the weights with an optimization algorithm that it can be gradient descent, Adam. There are many. This is very complex, but just what I want now is that you understand the principle. And then it optimizes, and then it modifies the weights here, and it starts again. And this is repeated, like it's a term that's called epochs, like, I don't know, 1,000 times, okay? And at the end, the our goal is once the system is trained, if we provide an X1 and an X2, the system is going to tell us whether this is a glioblastoma patient or it is not a glioblastoma patient. And believe me, the results are astonishing. I mean, it predicts very well, no matter how you try it. It is one of the most mind-blowing experiences to see how these artificial intelligence systems that are trained end up predicting very well anything that you can imagine. And I'm going to import the libraries that I need. And then because I'm going to try to teach the computer how to convert from Fahrenheit to Celsius, just training the system without giving the formula, but just for the sake of simplicity and to show how it works. Let me just, for example, define a function here that's going to be called var, and we're going to take the formula to convert from Celsius to Fahrenheit is going to take C, which is Celsius. We're going to convert it into Fahrenheit using this formula, and then it's going to return us the Fahrenheit degrees. So for example, if I try this, 100 degrees, it should give me 212 Fahrenheit. So 100 Celsius is 212 Fahrenheit. Okay, let's start coding the artificial intelligence. At first, we're going to show them the data that we have. So I'm going to define here like an array. Okay, so all I did here is to teach the system, to tell the system that we had some experimental results, and we checked as scientists that's minus 40 Celsius is equivalent to minus 40 Fahrenheit, minus 10 it's equivalent to 14 Fahrenheit, 0 it's 32, etc. Just with seven examples of this conversion, and you're going to see how quickly and efficiently knows the rule. Okay, so what I just did is to tell the system that I'm going to build a neural network with one hidden layer. The first one is going to have 3 neurons, and it's going to receive the input from one neuron, which is the one that we're going to use to pass the degrees Celsius. Okay, then we create a second hidden layer, again with 3 units, 3 neurons, and then the output is going to be just one again, because it's going to tell me just one number, how many Fahrenheit degrees are the Celsius that I introduced. And then I define the model, and it's going to be a sequential model, no need to know that, and inform the system, the computer, that I'm going to use this hidden layer, and this output. Okay, so now we're going to compile. And all I did here was to tell the system that this neural network is going to use an optimizer that's called Adam. It's one of the many optimizers there are. And that the loss function that I'm going to use is called mean squared error. So now the system knows exactly how this network needs to work. So what I did now is to tell the system that I want to train it using Celsius on the one hand, Fahrenheit as the output, and I want to train it 1,000 times. And you see, it is already trained. So it took like a few seconds, but the system now knows exactly how to convert without ever having given away the formula. So let's check now if it predicts correctly any Celsius degrees that I'm introducing. And let's check now how many Fahrenheit are these 100 Celsius. And if I do it, the system returns that it's 211.74. If we compare it here, it's 212 really, but remember, I never gave away the formula, so the system has learned. And in fact, let me show you how fast it did learn. Now, if I get this correctly, which I did, it shows a graph showing the loss. I mean, that is the inverse of the reliability or precision, and then the number of training cycles that I used. And I can see with less than 100, it will be more than enough to train it, because now the system is trained. So now, if you want to, we can try to understand what it did, but the thing is, it makes no sense to understand how the system did it, because we will never understand it, because this is a very simple system. But if we train a neural network that is very complex, it's going to be very difficult to understand why it did it. All we know is that it did it correctly because it self-adjusts. Okay, but let me show you for a sec. Sorry, I forgot to introduce that. I repeated the object and not the results, but here I have the weights that the neural network used, but I just don't care about the weights. I just care that the result was good. You may complain that this is not exactly 212, but if I just increase the number of units here and I tweak a little bit the parameters, I'm gonna get for sure the exact number. Let me check just not yet, but if I stay a little bit here and I compile it properly, I'm gonna get a more precise result. But remember, we didn't know the formula and the system just figured it out.
Very quickly, I'm going to give a very basic introduction to artificial intelligence and the field. And let me tell you that artificial intelligence is a huge branch of computer science that enables machines to perform tasks usually needing human intelligence. Machine learning is the largest branch of artificial intelligence, and it's defined by algorithms that are able to learn from data. And finally, neural networks or deep learning is probably machine learning on steroids. I mean, it is a special branch of machine learning that uses algorithms that simulate the behavior of neurons in our brains. But you may ask yourself, why then do we use all the rest? I mean, machine learning and everything else. Well, the caveat here is that deep learning needs a very large amount of data to train the systems. So sometimes when you do have a small amount of data, it is better to use machine learning. And let me tell you that the speed at which this field is growing is mind-blowing, honestly. I mean, it is insane, all the things that appear month after month. If you follow a little bit what the field is doing, you will immediately understand why this is going to be the future. So the video is getting now too long, maybe, but just to show you some examples of the machine learning applications that we were discussing before, let me show you very quickly some practical applications here in another notebook. I'm not going to be coding anymore now. Very quickly, just to let you know that, for example, here we're importing a data set that's called diabetes that I have here. And just a description of the data set. The data set tries to, using these attributes, age, sex, and all these surrogate biomarkers, wants to predict if someone is going to be a diabetic person, for example, and then we can create a data frame here. Yeah, sorry, I need to import. And as you can see here, I'm using a KNN model. And with this model, I will be able to train it and to fit it. Let me just
very quickly, just for you to see a practical application, as I was mentioning. Now it has been fitted, and now it has predicted something, and I can even change from KNN to linear regression, and these are new data from the prediction using another model, in this case linear regression. We can again change it, and now using a decision tree classifier or a random forest. And at the end of the day, the important thing is that we need to compare. This would be, by the way, the output of a decision tree system. And here at the end, I have coded a few cells, just trying to compare the predicted figures that I got with the real data that we have about these diabetic patients. And you can see clearly, without doing the regression, we can see clearly that it does predict in a quite reasonable way. Here, maybe even more clear. Exactly. And finally, let me just minimize this. And finally, let me just go to see some other examples of artificial intelligence here, just for the people that is interested in the stock market. We can see here the application for a portfolio of an efficient frontier. We can see here different ways of analyzing this efficient frontier, etc. We discussed about all that, just for you to see some examples. More artificial intelligence and machine learning used to predict the market. In this case, I used it to try and predict, let me show you, if I remember well, it was 1 day, 5-day returns, and 10-day returns. These are the results for the predictions for 1-day returns, 5-day returns, and then finally 10-day returns. And you can see how it is very clear. I mean, the way we get the data and the way the machine really helps us in identifying all the patterns. And finally, one thing that I love, as you know, I used to be a neurosurgeon before moving into the dark side of venture capital. Just kidding. I'm very interested in using CNNs, or convoluted neural networks, to diagnose reading images. And as you can see, this is a code, and I trained a model just to identify tumors using MRIs. And you're gonna see very quickly now, if I find it, yes, the real images that I introduced into the system, and the identification of the tumor here, just done by a machine. Again, not practical use, but it is really fascinating, all the things that you can do. And last but not least, the final thing that I'm going to show you. This is actually not my code. This is something that a friend of mine sent me, just to show the uses that we can, the uses of Python in synthetic biology. This will allow to work with synthetic biology models from a computer science environment. In fact, synthetic biology is the fusion, probably, between computer science and biology. Let me bring this. This is the cover of Nature. Nature magazine, as you know, is one of the most important sources of information in our sector, and it is already getting into the covers. I mean, all these artificial intelligence systems, you can try and find papers on synthetic biology and Python and biology, and I think it's gonna be the future of medicine indeed. So that's all for now. Remember that the point of this video is to show how powerful data science is, and if we apply it to our day-to-day activities, it could give us a very, very important advantage. This, again, is not about the future. This is about the present, because these technologies are already here, but they're not yet widely used. And I wonder why is that, because it amazes me that there's not a lot of people using this kind of tools. But I really wanted to show you how they are used, because I think If you ask the right questions, you get relevant answers, and I hope I will have inspired some of you maybe to try and understand better these technologies. But let me finish by saying that the new digital divide is going to be the artificial intelligence divide. Because again, it gives you, as I was mentioning at the beginning of the video, an unfair advantage. You should start now to understand better how these technologies work.